Okay, dear students, welcome to physics class of PU2. So in the previous class we have discussed about the electromagnetic induction. The phenomenon of electromagnetic induction we have discussed in the previous class. And what is electromagnetic induction? Whenever there is a change in the magnetic flux linked with the coil, an EMF and hence current is induced in the coil. This phenomenon is called as the electromagnetic induction. So also we have discussed the experiments of Faraday and Henry to understood the phenomenon of electromagnetic induction. That is, the current is induced by moving a magnet and current is induced by moving a neighboring coil, and the current is induced by changing the current in the neighboring coil. So these three experiments we have studied, and also what the phenomenon of the electromagnetic induction we have studied in the previous class. Now here we have to study about the Faraday's law of electromagnetic induction. The Faraday's law of electromagnetic induction. How to calculate the induced EMF? This gives the idea about the Faraday's law. So what is electromagnetic induction? Whenever there is a change in the magnetic flux linked with the coil, an EMF and hence current is induced in the coil. This phenomenon is called as what? The electromagnetic induction. But how to find the induced EMF or how to calculate the induced EMF? That can be calculated by here using the Faraday's law of electromagnetic induction. Right? So for example here, d pi 1 is the flux. D pi 1 is the flux at time t1, at time t equal to 0. Again, d pi 2 is the magnetic flux at time t is equal to t1, at some other instant of time t1. Now, what is the change in the magnetic flux here? Then change in the magnetic flux is equal to what? D pi 2 minus d pi 1, so that is equal to what? D pi. So what is d pi here? D pi is the small change in the magnetic flux. So d pi is small change in the magnetic flux, or the magnetic flux, change in the magnetic flux passing through the what? Coil here. D pi is the small change in the magnetic flux in a small interval of time dt or delta t, right? In a small interval of time, dt, right? D pi is the flux at time t equal to 0 and d pi 2 is the flux at time t equal to t1. Now d pi 2 minus d pi 1 is what? The d pi. D pi is what? The small change in the magnetic flux which changes through the what? A coil, or which is passing through the change in the magnetic flux passing through the coil, right? D pi is the small change in the magnetic flux in a small interval of time dt. Then what is the rate? What is the time rate of change of magnetic flux that will be linked with the coil here? So d pi by dt, it is equal to what? The time rate of change of magnetic flux linked with the coil. D pi by dt is the time rate of change of magnetic flux linked with the coil. Then the EMF, the induced EMF, that can be calculated here. So according to Faraday's law of electromagnetic induction, the magnitude of the induced EMF is directly proportional to the time rate of change of magnetic flux linked with the coil. That is equal to what here? D pi by dt, or the induced EMF is directly proportional to what? The time rate of change of magnetic flux linked with the coil. So that is d pi by dt, and here the proportionality constant we take here the -1. Therefore E is equal to, that is the induced EMF is equal to minus d pi by dt. So we'll consider this minus sign in shortly. So what is the minus sign which indicates? We'll explain you. So that is what here. So induced EMF E is equal to d pi by dt. That means what here? The Faraday's law of electromagnetic induction states what here? The induced EMF, the magnitude of the induced EMF is equal to the rate of change of magnetic flux linked with the coil, or linked with the coil here, that we have to state here. So the magnitude of the induced EMF is equal to what here? The rate of change of magnetic flux linked with the coil, right? So let us write the statement here. Statement form. So there will be a 1 mark portion, or state and explain the Faraday's law of electromagnetic induction for 2 marks. So what is the statement for Faraday's law of electromagnetic induction? The magnitude of the induced EMF, the magnitude of the induced EMF the magnitude of the induced EMF in a coil is equal to the rate of change of magnetic flux linked with the coil. The rate of change of magnetic flux linked with the coil, or linked with it, right? Therefore the EMF, induced EMF, is equal to d pi by dt. The magnitude of the induced EMF in a coil is equal to the rate of change of magnetic flux linked with the coil. So if d pi is what here? The small change in the magnetic flux in a small interval of time, dt. Therefore E is equal to minus d pi by dt. So if coil contains n number of turns, right? This is for one turn. If coil consists of n number of turns, if coil consists of n number of turns, then what we can write here? E is equal to d pi by dt with n. So n indicates what? For n number of turns which contains in the coil. So this is the Faraday's law of electromagnetic induction here, right? The magnitude of the induced EMF in a coil is equal to the rate of change of magnetic flux linked with the coil. So E is equal to d pi by dt. For n number of turns, E is equal to n into d pi by dt. So one of the main important point we have to mention here, that is what? It does not give any idea about the direction of the induced EMF or the direction of the induced current, right? So later on, the German physicist, the Heinrich Friedrich Lenz, he given the polarity of the induced EMF or the direction of the induced current. So the direction of the induced EMF or the induced current is identified or is detected by what here? By the Lenz's law, right? The Lenz's law gives the polarity of the induced EMF. ಯಾವ direction current induce ಆಗ್ತದ, so ಯಾವ direction EMF ಬರ್ತದ ಅನ್ನೋದನ್ನ idea Faraday's law ಕೊಡಂಗಿಲ್ಲ. So the Lenz's law gives the polarity or the direction of the induced EMF, right? That is minus. Why this minus we have to consider here? That polarity of the induced EMF is given by the Lenz's law, right? What is Lenz's law and why we have to take minus sign here? Let us discuss it. So with the discussion of the Lenz's law, let us see here why we have to mention in this RHS side here. That is E is equal to minus d pi by dt, or E is equal to minus n into d pi by dt. The polarity of the induced EMF or the direction of the induced current, it is given by the Lenz's law. Now let us discuss here the statement and explanation of the Lenz's law and why we have to consider here the minus sign. So the Faraday's law is equal to what here? E is equal to d pi by dt. It is E is equal to d pi by dt is given by what? The Faraday's law, and minus sign is given by the Lenz's law here. So why we have to take the minus sign? Let us discuss here with the Lenz's law. So once again I will show you here the coil and magnet experiment. Then we'll study about the Lenz's law here, right? So you can observe here. So I have here bar magnet here, that is N pole, and this is what S pole, right? Now I move this bar magnet towards and away from the coil, and you observe the deflection in the galvanometer. That is, the galvanometer is used to what? Detect the presence of the electric current, right? Whenever there is a change in the magnetic flux linked with the coil, an EMF and hence current is induced in the coil. So this coil is connected to galvanometer here, right? There is no external source, but we are getting the current due to the change in the magnetic flux, right? So just you observe here, I hold this bar magnet towards the coil, but there is no deflection in the galvanometer, right? When I move this bar magnet towards and away from the coil, so there is a deflection in the galvanometer. You can observe here, right? When the bar magnet is moved towards the coil, it shows the deflection. Away from the coil, opposite direction, right? When the N pole is moved towards ಆ ಕಡೆ ಸೈಡ್ ಡಿಫ್ಲೆಕ್ಷನ್ ತೋರಿಸ್ತದೆ. ಅವೇ ಫ್ರಮ್ ದ ಕಾಯಿಲ್ ಮೂವ್ ಮಾಡಿದಾಗ ಈ ಸೈಡ್ ಡಿಫ್ಲೆಕ್ಷನ್ ತೋರಿಸ್ತದೆ, ರೈಟ್? ಆರ್ ಯು ಅಬ್ಸರ್ವಿಂಗ್ ದಿಸ್, ರೈಟ್? ಈ ಕಡೆ ಮೂವ್ ಮಾಡ್ತೀನಿ, ರೈಟ್ ಸೈಡ್ ಡಿಫ್ಲೆಕ್ಷನ್ ತೋರಿಸ್ತದೆ, ರೈಟ್? ಈ ಕಾಯಿಲನ್ನು ಅವೇ ಫ್ರಮ್ ಬಾರ್ ಮ್ಯಾಗ್ನೆಟನ್ನು ಅವೇ ಫ್ರಮ್ ದ ಕಾಯಿಲ್ ಮೂವ್ ಮಾಡ್ತೀನಿ, ಲೆಫ್ಟ್ ಸೈಡ್ ಡಿಫ್ಲೆಕ್ಷನ್ ತೋರಿಸ್ತದೆ, ರೈಟ್? ಟುವರ್ಡ್ಸ್ ಅವೇ, right? As I move, the rate of change of magnetic flux within the coil, right, changes. Whenever there is change in the magnetic flux linked with the coil, an EMF and hence current is induced in the coil ಅಂತ ಹೇಳ್ತೀವಿ, right? But it is directly proportional to what? The induced current or the induced EMF is directly proportional to the rate of change of magnetic flux. ಅಂದರೆ ನೀವು ಎಷ್ಟು ಫಾಸ್ಟಾಗಿ ಮಾಡ್ತೀರಿ ಅಷ್ಟು ಡಿಫ್ಲೆಕ್ಷನ್ ಜಾಸ್ತಿ ಬರ್ತದೆ. You can observe here, right? So now let us understood here why the deflection, that is the direction of the current changes, right? Let us understood here the Lenz's law. Just you observe here, N pole move ಮಾಡಕತ್ತೇನ್ರಿ, right? I am moving here N pole towards and away, I am moving the N pole of the bar magnet. Now S pole move ಮಾಡಿದ್ರೆ ಅದರದ್ದು ಅಪೋಸಿಟ್ ಬರ್ತದೆ ನೋಡ್ರಿ. So I am moving S pole of the bar magnet, ಅದ್ರದ್ದು N ಪೋಲ್ಗೆ ಏನು ಬಂದಿರ್ತದೆ ಅದ್ರದ್ದು ಅಪೋಸಿಟ್ ಡೈರೆಕ್ಷನ್ಸ್ ಈಗ S ಪೋಲ್ಗೆ ಬರ್ತದೆ. ಫಾಸ್ಟಾಗಿ ಮಾಡಿದರೆ ಡಿಫ್ಲೆಕ್ಷನ್ ಜಾಸ್ತಿ ಬರ್ತದೆ. ದಟ್ ಮೀನ್ಸ್ ವಾಟ್? ದ ಇಂಡ್ಯೂಸ್ಡ್ EMF is directly proportional to the rate of change of magnetic flux linked with the coil ಅಂತ ಹೇಳ್ತೀವಿ, right? So all of you observe the deflection in the galvanometer. Now let us study here the Lenz's law. So what the Lenz's law states here, the direction of the induced EMF is such that the induced current is always opposes the cause of its production, right? So the formula is what here, that induced EMF of the current is equal to minus d pi by dt, right? Which opposes the cause of its production. The induced EMF is such that the induced current always opposes the cause of its production. So ನಮಗೆ EMF ಅಥವಾ ಕರೆಂಟ್ ಯಾವುದು ಸಲುವಾಗಿ ಇಂಡ್ಯೂಸ್ ಆಗತ್ತೈತ್ರಿ? ಬೈ ಚೇಂಜಿಂಗ್ ದ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫ್ಲಕ್ಸ್ ಲಿಂಕ್ ವಿತ್ ದ ಕಾಯಿಲ್. ಸೊ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫ್ಲಕ್ಸ್ ಚೇಂಜ್ ಮಾಡೋದ್ರಿಂದ ಕರೆಂಟ್ ಇಂಡ್ಯೂಸ್ ಆಗತ್ತೈತ್ರಿ. ಸೊ ದ ಡೈರೆಕ್ಷನ್ ಆಫ್ ದಿ ಕರೆಂಟ್ ಈಸ್ ಸಚ್ ದ್ಯಾಟ್ ಇಟ್ ಆಲ್ವೇಸ್ ಅಪೋಸಸ್ ದ ಕಾಸ್ ಆಫ್ ಪ್ರೊಡಕ್ಷನ್. ಇಲ್ಲಿ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫ್ಲಕ್ಸ್ ಚೇಂಜ್ ಆಗೋದನ್ನು ಅಪೋಸ್ ಮಾಡ್ತದೆ ಯಾವುದ್ರಿ? ಕರೆಂಟ್. ಆ ಡೈರೆಕ್ಷನ್ ಒಳಗೆ ಕರೆಂಟ್ ಇಂಡ್ಯೂಸ್ ಆಗ್ತದೆ. ಅಪೋಸ್ ಮಾಡುವಂಥ ಡೈರೆಕ್ಷನ್ ಒಳಗೆ ಕರೆಂಟ್ ಇಂಡ್ಯೂಸ್ ಆಗ್ತದೆ. So see here, there is a coil AB. This is the face A of the coil and this is face B of the coil. So you can observe here. Let us consider here, right? So this is the face. This is one face of the coil and this is another face of the coil, right? Face A and face B, right? I have a bar magnet here, right? N pole of the bar magnet, it is moved towards the coil. So ಅವಾಗ ಏನಾಗ್ತದೆ ನೋಡ್ರಿ. So when N pole of the bar magnet is moved towards the coil, this phase acts as a N pole in such a way the direction of the current is induced. So aವಾಗ ಏನಾಗುತ್ತೆ, the face of the coil should act as a N pole. That means what? There should be a anti-clockwise current in it. So anti-clockwise direction of current button. There is a current in the anti-clockwise direction, so that this phase acts as a what? The N pole. So now we got bar magnet that is changing the magnetic flux. The N pole of the bar magnet, it is moving towards the coil. Towards the coil na move ಮಾಡಕತ್ತಾಗ ಏನಾಗ್ತದ್ರಿ, direction of current ಯಾವ direction ಅಲ್ಲಿ ಬರ್ತದೆ, anti clockwise direction ಅಲ್ಲಿ ಬರ್ತದೆ. Anti clockwise direction of current ಇತ್ತಂದ್ರೆ ಆ ಫೇಸ್ ಯಾವ ಫೇಸ್ ಅಂತ ಆಕ್ಟ್ ಆಗ್ತಿದೆ, ಇದು N pole ಅಂತ ಆಕ್ಟ್ ಆಗ್ತದೆ. This face of the coil will act as a what? The N pole. N pole act ಆಗ್ತಂದ್ರೆ ಏನಾಗ್ತದೆ, so this face becomes, the face of the coil becomes N pole, and here we have the N pole. So there is a repulsion. ಅಂದ್ರೆ ಏನಾಗ್ತದೆ, ಇದನ್ನ ರಿಪೆಲ್ ಮಾಡ್ತದೆ. This bar magnet is repelled. That means what? It opposes the cause of its production. Now bar magnet ಅನ್ನ coil ಕಡೆ ಮೂವ್ ಮಾಡಿ ಏನು ಮಾಡಕತ್ತೀವಿ, ಕರೆಂಟ್ ಇಂಡ್ಯೂಸ್ ಮಾಡಕತ್ತೀವಿ. ಸೊ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫ್ಲಕ್ಸ್ ಅನ್ನ ಚೇಂಜ್ ಮಾಡಕತ್ತೀವಿ. ಸೊ ಇಲ್ಲಿ ಡೈರೆಕ್ಷನ್ ಆಫ್ ಕರೆಂಟ್ ಯಾವ ರೀತಿಯಾಗಿ ಬರ್ತದೆ, ಆಂಟಿ ಕ್ಲಾಕ್ವೈಸ್ ಡೈರೆಕ್ಷನ್ ಆಫ್ ಕರೆಂಟ್ ಇಂಡ್ಯೂಸ್ ಆಗಿ ಈ ಫೇಸ್ N ಪೋಲ್ ಅಂತಾಗಿ ಏನಾಗ್ತದೆ, ಇದನ್ನ ಅಪೋಸ್ ಮಾಡ್ತದೆ. ದಟ್ ಮೀನ್ಸ್ ದೇರ್ ಈಸ್ ಎ ರಿಪಲ್ಷನ್. ಇದನ್ನ ಬಾರ್ ಮ್ಯಾಗ್ನೆಟ್ ಅನ್ನ ರಿಪೆಲ್ ಮಾಡ್ತೈತಿ. ಇದು ಯಾವುದು, ಕಾಯಿಲ್. ಅಂದ್ರೆ ಏನಾಗ್ತೈತ್ರಿ, ವಿಚ್ ಅಪೋಸಸ್ ದ ಚೇಂಜ್ ಇನ್ ದ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫ್ಲಕ್ಸ್. ನಾವೇನು ಇದನ್ನ ಬಾರ್ ಮ್ಯಾಗ್ನೆಟ್ ಅನ್ನ ಮೂವ್ ಮಾಡಕತ್ತೀವಿ, ಈ ಫೇಸ್ ಏನಾಗ್ತೈತ್ರಿ N ಪೋಲ್ ಅಂತಾಗಿ ದೇರ್ ಈಸ್ ಎ ರಿಪಲ್ಷನ್ ಬಿಟ್ವೀನ್ ದಿ ವಾಟ್ ದ ಫೇಸ್ ಆಫ್ ದ ಕಾಯಿಲ್ ಅಂಡ್ ದಿ ಬಾರ್ ಮ್ಯಾಗ್ನೆಟ್. ಬಾರ್ ಮ್ಯಾಗ್ನೆಟ್ ಅನ್ನ ರಿಪೆಲ್ ಮಾಡ್ತದೆ. ಆಂಟಿ ಕ್ಲಾಕ್ವೈಸ್ ಡೈರೆಕ್ಷನ್ ಒಳಗೆ ಕರೆಂಟ್ ಇಂಡ್ಯೂಸ್ ಮಾಡಿಕೊಂಡು ಈ ಫೇಸ್ N ಪೋಲ್ ಅಂತ ಆಕ್ಟ್ ಆಗಿ ದೇರ್ ಈಸ್ ಎ ರಿಪಲ್ಷನ್ ಬಿಟ್ವೀನ್ ದಿ ವಾಟ್ that bar magnet is repelled by the what? The current here, that is by the coil here, right? So this is what the lenses for here. The direction of the induced EMF is such that the induced current always opposes the cause of its production. The induced current opposes the cause of its production. ಅಂದ್ರೆ ಏನ್ರಿ, ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫ್ಲಕ್ಸ್ ಚೇಂಜ್ ಮಾಡೋದನ್ನ ಅಪೋಸ್ ಮಾಡಕತ್ತೀವಿ. ನಾವು N ಪೋಲ್ ಆಫ್ ದ ಬಾರ್ ಮ್ಯಾಗ್ನೆಟ್ ಅನ್ನ ಕಾಯಿಲ್ ಕಡೆ ಮೂವ್ ಮಾಡಕತ್ತೇವೆ. ಕಾಯಿಲ್ ಕಡೆ ಮೂವ್ ಮಾಡೋದ್ರಿಂದ ಏನಾಗ್ತದೆ, ಆಂಟಿ ಕ್ಲಾಕ್ವೈಸ್ ಡೈರೆಕ್ಷನ್ ಕರೆಂಟ್ ಇಂಡ್ಯೂಸ್ ಆಗ್ತದೆ. ಸೊ ಆಂಟಿ ಕ್ಲಾಕ್ವೈಸ್ ಡೈರೆಕ್ಷನ್ ಕರೆಂಟ್ ಇಂಡ್ಯೂಸ್ ಆಯ್ತಂದ್ರೆ ಈ ಫೇಸ್ ಏನಾಗ್ತೈತ್ರಿ, ಕಾಯಿಲ್ ಫೇಸ್ N ಪೋಲ್ ಅಂತ ಆಕ್ಟ್ ಆಗಿ ಅದನ್ನ ರಿಪೆಲ್ ಮಾಡ್ತದೆ. ಚೇಂಜ್ ಮಾಡೋದನ್ನ ರಿಪೆಲ್ ಮಾಡ್ತದೆ. ನಾವು ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫ್ಲಕ್ಸ್ ಅನ್ನ ಚೇಂಜ್ ಮಾಡ್ತೀವಿ, ಅದನ್ನ ಅಪೋಸ್ ಮಾಡ್ತದೆ. ಅಂದ್ರೆ ಮ್ಯಾಗ್ನೆಟ್ ಮುಂದೆ ಬರೋದನ್ನ ರಿಪೆಲ್ ಮಾಡ್ತದೆ. ಸೊ ದಿಸ್ ಈಸ್ ಒನ್ ಕೇಸ್. ಸೊ ಅನದರ್ ಕೇಸ್ ಇಸ್ ವಾಟ್ ಹಿಯರ್, when the bar magnet is moved away from the coil. away from the coil ಮೂವ್ ಮಾಡೋದ್ರಿಂದ ನಾವು ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫ್ಲಕ್ಸ್ ಚೇಂಜ್ ಮಾಡಕತ್ತೀವಿ, ರೈಟ್? ಈ ರೀತಿ ಆಗೋದ್ರಿಂದ ಏನಾಗ್ತದೆ, ಇಲ್ಲಿ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫ್ಲಕ್ಸ್ ಇನ್ಕ್ರೀಸ್ ಆಗ್ತದೆ, ಇಲ್ಲಿ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫ್ಲಕ್ಸ್ ಡಿಕ್ರೀಸ್ ಆಗ್ತದೆ. ಸೊ ಅಗೇನ್ ವಾಟ್ ಹ್ಯಾಪನ್ಸ್ ಹಿಯರ್, ಐ ಆಮ್ ಮೂವಿಂಗ್ ದ ಬಾರ್ ಮ್ಯಾಗ್ನೆಟ್ ಅವೇ ಫ್ರಮ್ ದಿ ಕಾಯಿಲ್. ಅವೇ ಫ್ರಮ್ ದಿ ಕಾಯಿಲ್ ಅಂತ ಹೇಳಿದ್ರೆ N ಪೋಲ್ ಆಫ್ ದ ಬಾರ್ ಮ್ಯಾಗ್ನೆಟ್, ಐ ಆಮ್ ಮೂವಿಂಗ್ ಇಟ್ ಅವೇ ಫ್ರಮ್ ದಿ ಕಾಯಿಲ್. ಅವೇ ಫ್ರಮ್ ದ ಕಾಯಿಲ್ ಮೂವ್ ಮಾಡುವಾಗ ಏನಾಗ್ತದೆ ನೋಡ್ರಿ, ಅಗೇನ್ ಯು ಆರ್ ಚೇಂಜಿಂಗ್ ದ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫ್ಲಕ್ಸ್ ಲಿಂಕ್ಡ್ ವಿತ್ ದ ಕಾಯಿಲ್. ಮತ್ತೆ ನಾವಿಲ್ಲಿ ಏನು ಮಾಡಕತ್ತೀವಿ, that is we are changing the magnetic flux linked with the coil. ಈ ಕೇಸ್ ದೊಳಗೆ ಏನಾಗ್ತದೆ, the current is induced in clockwise direction. the direction of current change ಆಗ್ತದೆ. ಇಲ್ಲಿ ಆಂಟಿ ಕ್ಲಾಕ್ವೈಸ್ ಡೈರೆಕ್ಷನ್ ಇದ್ದಿದೆ, ಇಲ್ಲಿ ಕ್ಲಾಕ್ವೈಸ್ ಡೈರೆಕ್ಷನ್ ಒಳಗೆ ಕರೆಂಟ್ ಬರುತ್ತೆ ಅವೇ ಫ್ರಮ್ ದಿ ಮೂವ್ ಮಾಡುವಾಗ. ಸೊ ಆಸ್ ಯು ಅಬ್ಸರ್ವ್ಡ್ ಇನ್ ದ ಗ್ಯಾಲ್ವಾನೋಮೀಟರ್, ರೈಟ್? N ಪೋಲ್ ಮೂವ್ ಮಾಡುವಾಗ ಟುವರ್ಡ್ಸ್ ಮೂವ್ ಮಾಡುವಾಗ ಈ ಡೈರೆಕ್ಷನ್ ಒಳಗೆ ಬರ್ತಾ ಇದ್ರಿ, ಅವೇ ಫ್ರಮ್ ದಿ ಕಾಯಿಲ್ ಮೂವ್ ಮಾಡುವಾಗ ಅಪೋಸಿಟ್ ಡೈರೆಕ್ಷನ್ ಒಳಗೆ ಬರ್ತಾ ಇತ್ತು. ಸೊ ಇಲ್ಲಿ ಏನಾಗ್ತೈತ್ರಿ, ಈಗ ಆಂಟಿ ಕ್ಲಾಕ್ವೈಸ್ ಡೈರೆಕ್ಷನ್ ಒಳಗೆ ಕರೆಂಟ್ ಬರ್ತದೆ ಯಾವಾಗ ಬಾರ್ ಮ್ಯಾಗ್ನೆಟ್ ಅನ್ನ ಅವೇ ಫ್ರಮ್ ದಿ ಕಾಯಿಲ್ ಮೂವ್ ಮಾಡಿದ್ರೆ. ಸೊ ಅವಾಗ ಏನಾಗ್ತೈತ್ರಿ, ಎಸ್ ಪೋಲ್ ಆಗುತ್ತೆ. ಸೊ ದಿಸ್ ಫೇಸ್ ಆಫ್ ದ ಕಾಯಿಲ್, this face of the coil will act as a what here, the S pole. S pole ಅಂತ ಆಗ್ತದೆ. So this will act as S pole and there is a N pole in this side. So in that case what happens, it attracts. ಅಂದ್ರೆ ಏನ್ರಿ, ನಾವು ಬಾರ್ ಮ್ಯಾಗ್ನೆಟ್ ಅನ್ನ ಅವೇ ಫ್ರಮ್ ದ ಕಾಯಿಲ್ ಮೂವ್ ಮಾಡಿ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫ್ಲಕ್ಸ್ ಚೇಂಜ್ ಮಾಡಕತ್ತಿದ್ದು, ಇಲ್ಲಿ ಏನಾಗ್ತೈತ್ರಿ, ಅದನ್ನ ಚೇಂಜ್ ಮಾಡೋದನ್ನ ಅಪೋಸ್ ಮಾಡಿ ಅದನ್ನ ಬಾರ್ ಮ್ಯಾಗ್ನೆಟ್ ಅನ್ನ ಅಟ್ರಾಕ್ಟ್ ಮಾಡ್ತೈತಿ. ಅಗೇನ್ ದೇರ್ ಈಸ್ ಎ ಇಂಡ್ಯೂಸ್ಡ್ EMF and induced current. So in this way we have to understand the Lenz's law here, right? The direction of induced EMF is, this is clockwise. The direction of the induced EMF is such that the induced current always opposes the cause of its production. ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫ್ಲಕ್ಸ್ ಚೇಂಜ್ ಆಗೋದನ್ನು ಅಪೋಸ್ ಮಾಡ್ತದೆ. ಯಾವ ರೀತಿಯಾಗಿ ಆ ಅಪೋಸ್ ಮಾಡೋ ಡೈರೆಕ್ಷನ್ ಒಳಗೆ ಕರೆಂಟ್ ಇಂಡ್ಯೂಸ್ ಆಗ್ತದೆ. ಈ ಕೇಸ್ ಒಳಗೆ ಏನಾಗ್ತದೆ, ಬಾರ್ ಮ್ಯಾಗ್ನೆಟನ್ನು ಟುವರ್ಡ್ಸ್ ದ ಕಾಯಿಲ್ ಮೂವ್ ಮಾಡಿದಾಗ ಏನಾಗ್ತದೆ, ಈ ಫೇಸ್ ಎನ್ ಪೋಲ್ ಅಂತ ಆಕ್ಟ್ ಆಗ್ತದೆ. ಅವಾಗ ಕರೆಂಟ್ ಆಂಟಿ ಕ್ಲಾಕ್ ವೈಸ್ ಡೈರೆಕ್ಷನ್ ಒಳಗೆ ಇರ್ತದೆ. ದೇರ್ ಈಸ್ ಎ ರಿಪಲ್ಷನ್, ದಟ್ ಮ್ಯಾಗ್ನೆಟ್ ಈಸ್ ರಿಪೆಲ್ಡ್ ಹಿಯರ್. ಇಲ್ಲಿ ಏನಾಗ್ತದೆ, we are moving the bar magnet away from the coil, right? Away from the coil move ಮಾಡಬೇಕಾದ್ರೆ ಏನಾಗ್ತದೆ, the current is induced in clockwise direction, and this phase acts as what? This phase acts as what? S pole, and the bar magnet attracts you. That means what? Always it opposes the cause of production. Magnetic flux change ಮಾಡುವುದನ್ನ ಅಪೋಸ್ ಮಾಡ್ತೈತ್ರಿ, ಆ ಡೈರೆಕ್ಷನ್ ಒಳಗೆ ಕರೆಂಟ್ ಇಂಡ್ಯೂಸ್ ಆಗ್ತದೆ. So this is the simple law. That is what the Lenz's law here. The polarity of ಇಲ್ಲಿ ನೆಗೆಟಿವ್ ಸೈನ್ ಇಂಡಿಕೇಟ್ ಮಾಡ್ತೀವಿ. ಸೊ ನೆಗೆಟಿವ್ ಸೈನ್ ಇಂಡಿಕೇಟ್ಸ್ ವಾಟ್ ಹಿಯರ್, ಇಟ್ ಆಲ್ವೇಸ್ ಅಪೋಸಸ್ ದ ಕಾಸ್ ಆಫ್ ಇಟ್ಸ್ ಪ್ರೊಡಕ್ಷನ್. ದ ಕರೆಂಟ್ ಯಾವುದರಿಂದ ಬರಕತ್ತೈತಿ ಅದನ್ನು ಅಪೋಸ್ ಮಾಡೋ ಡೈರೆಕ್ಷನ್ ಒಳಗೆ ಕರೆಂಟ್ ಇಂಡ್ಯೂಸ್ ಆಗ್ತದೆ. ಅದು ಲೆಂಜಸ್ ಲಾ ಹೇಳ್ತಾರೆ. ಸೊ ದಿಸ್ ಇಸ್ ದ ಸಿಂಪಲ್ ಪಾಯಿಂಟ್ ಹಿಯರ್ that we can understood easily. That is the Lenz's law here. One more important point what we have to understood here, this Lenz's law supports the law of conservation of energy, right? The Lenz's law supports the law of conservation of energy. Energy can neither be created nor be destroyed, but it can be converted from one form to another form ಅಂತ ಹೇಳ್ತೀವಿ. ಬಟ್ ಈ EMF ಇಂಡ್ಯೂಸ್ ಆಗ್ತಾ ಇದೆ ಅಂತಂದ್ರೆ ಏನಾಗಬೇಕು, ಇಲ್ಲಿ ಸಮ್ ಅದರ್ ಫಾರ್ಮ್ ಆಫ್ ಎನರ್ಜಿ ಇಸ್ ಕನ್ವರ್ಟೆಡ್ ಇಂಟು ಅದರ್ ಫಾರ್ಮ್. ಸೊ ಇಲ್ಲಿ ನಾವು ಏನು ಮಾಡಕತ್ತೀವಿ, ಮೆಕ್ಯಾನಿಕಲ್ ವರ್ಕ್ ಮಾಡಕತ್ತೀವಿ. To move the bar magnet towards and away from the coil, we are doing what? The mechanical work, right? That mechanical work is converted into what here? The energy. That is what the EMF here. To move the bar magnet towards and away from the coil, we are doing the work. That work appears as the energy in the form of induced EMF in the coil. Now we need work ಮಾಡಕತ್ತೀವಿ. That work is converted into energy in the form of EMF, that is induced in the coil here. So therefore what here, that induced EMF is in accordance with the what? The law of conservation of energy. So what is the significance of the Lenz's law anta kelidaga, there will be one more question. What is the significance of the Lenz's law? That is what? The law of conservation of energy, right? The law of conservation of energy is support the Lenz's law. It supports the law of conservation of energy. That means what? Whatever we are doing the work to move the magnet towards and away from the coil, that mechanical work is converted into what? The energy. So hence it is what? The Lenz's law supports the law of conservation of energy. So in this way you have to understand the two important laws here. One is the Faraday's law of electromagnetic induction, and another one is what? The Lenz's law, that will give the direction of the induced current. So first one, the magnitude of the induced EMF that can be calculated, that can be determined by using the Faraday's law of electromagnetic induction, that is E is equal to d pi by dt. And this negative sign, the direction of the induced EMF or the induced current, that can be determined by the Lenz's law, right? The direction of the induced EMF or the induced current is always such that it opposes the cause of its production, that is the change of magnetic flux. That is what the negative sign is given here, right? And it also supports the law of conservation of energy. That means what? Whatever we are doing the whatever we are doing the mechanical work here, that mechanical work is converted into what here? The energy in the form of induced EMF in the coil. So hence we have to state here the law of conservation of energy also, right? So please go to the points once again, right? It is Faraday's law of electromagnetic induction, which will be one or two more question. And again the Lenz's law, it is the significance of the Lenz's law, that is the law of conservation of energy, which is one more question. Again state and explain the Lenz's law, it is also a 2 or 3 mark question. So in the next video class we will discuss about the next point related to what? The electromagnetic induction. Thank you students.